blowpipe is basically a specially made curved metal tube that allows one to blow through the flame of a candle or a lamp. In so doing, the oxygen in your breath changes the flame and makes it much hotter. This was a common scientific tool in Smithson's time, and he was uncommonly skillful in using it. A typical way to use the blowpipe was to crush the material being tested and to place it in a depression in a piece of charcoal. The charcoal thus served as a way to hold the sample and to protect one's fingers against the heat of the flame, which could be surprisingly intense. The heating of the charcoal itself assists in the release of the zinc. A simple blowpipe, used with an oil lamp and a charcoal holder, could reach temperatures as high as 2,000 degrees Fahrenheit. Since this was known to be as hot as the temperatures reached in the furnaces used to make brass, Smithson's blowpipe test provided a model of how the different calamine ores would act during the smelting process. When zinc carbonate is powdered and subjected to the heat of the blowpipe, it rapidly melts and the zinc vaporizes. The vaporized zinc immediately combines with oxygen and redeposits back on the charcoal. This was the test. When it was over, the white powder left on the charcoal, which Smithson identified as zinc oxide, proved that the zinc would be released in the foundry furnace. Thus, zinc carbonate was a good ore to use for making brass. When zinc silicate is powdered and subjected to the heat of the blowpipe, it reacts differently. The sample heats rapidly, but fails to release its zinc. After the test is completed, the lack of a white powder on the charcoal shows that this ore, zinc silicate, is a poor choice for making brass and should be avoided.